Hello class of 2018. Today we're looking at the normal distribution and we're using the standard probability limits. That means we're taking steps away from the mean of 1, 2 and 3 standard deviations, and we're also going to use a standardized variable formula to convert from x to z and vice versa. So here's a visual of the 68, 95, 99.7% rule. The rule says that 68% of the values of all the distribution will lie between one standard deviation of the mean either side. So that's the mean. We have one standard deviation positive and one standard deviation in a negative direction. 95% of the values lie within two standard deviations, and 99.7% lie within three standard deviations. So what I'm actually going to do is I'm going to draw in a little axis down the bottom here, and this is the x1. So here these are all z's, the standard distribution, and so here along this bottom line here, that would be the mean in x, whatever the mean is. So it could be 10 or something, and from our previous example we might have a mean of 3, so this would be one standard deviation away from the mean, if that makes any sense at all. Then what we have is the formula z equals x minus mu on sigma, which converts from the regular or general normal distribution with a mean of mu and a standard deviation of sigma to a standardized normal distribution which has a mean of 1 and a standard deviation of 0. Mu is the mean in x, standard deviation in x is sigma, z is the standard normal value, and x is the observed normal value. A negative z value is below the mean and a positive z value is above the mean. So again, a little picture for you is if I have this bit here, this part here will all have z values that are positive, and this part here will all have z values that are negative. So here's an example. We have a distribution of blood pressures that's normal. Don't really worry about that, it's kind of extra. With a mean of 120 and a standard deviation of 10, and this is just units of measurement. So if I draw my sketch first based on what I'm told, I have a center of 120 and one standard deviation is 130 and one standard deviation the other way is 110. Now, you're asked to find the percentage that have blood pressure between 100 and 140. So if I make a little note on the diagram of another standard deviation away, I have 140 and 100. So this is actually in the two standard deviations away range. So it's 120 minus 2 lots of 10 and 120 plus 2 lots of 10. Now you don't have to write this line in, it's just for me to explain what's going on. And so that means that 95% will lie within those values. Now for part B, we're looking at the probability that the blood pressures are greater than 130. So once again, I draw my picture. Here's my mean, which should be centered, 120. One step to the right is 130. And I know that between there and there is 68% of the values. Therefore, this part in here is actually 34% of the values. So this means that I can rewrite this as the probability of x being greater than 120 minus the probability of x being between 120 and 130, which in picture form looks like this. I have this half bit here, That's 120 minus the bit in between here, which is 120 to 130. So I know that the total probability on the halfway mark is 0.5, so that's 50%. And I know that this part in here is 34%, which I'll put in blue. So therefore the answer is 50 take 34, which is 16%. So 16% of the values will be above 130. And last but not least, we have the probability between 90 and 110. So once again, I'll draw my picture. That's 120 there. 110 is one standard deviation less, and 90 is 3 standard deviations less. So what I use is the two properties together. I've got that 99.7 lie between 90, 120 to 150. And I also know that 68% lie between 110 and 130. So if I look at the first bit, I know that between 90 and 120 has to be half of 99.7%, and that works out to be 49.85% between there and there. Here. The other thing I know is that between 110 and 120, not quite to scale, between there and there is half of 68%, and that is 34%. Therefore, the probability that x is between 90 and 110 is 49.85%, take away 34%, which is 15.85%. Now for this one, you've got two results, so you need to do two calculations, and you need to convert them both to a standardized mark, and then you need to decide which one Brian did better in. So it's helpful to write out the formula here, z equals x, whatever the value is, minus mu over sigma. And so for biology, which I will code with blue, his standardized value was 77. Take away the mean of biology, so it's 68.5, divided by the standard deviation for biology, 4.9. And after a little bit of calculation, it's 1.73469. For history, which I will go with red, history, he got 79, and the mean for history was 75.3, and the standard deviation was 4.1. And his answer, this answer for the Z was 0.902439. So we have then a standardized mark for Brian that is 1.73 in biology and 0.90 for history, which means that Brian did better in biology. So ZB is greater than ZH. Therefore, Brian did better in biology relative to his peers.